And remember, on exam 3, we're going to cover material from chapter 5 and chapter 6. Okay, so I'm going to ask you questions like, what? What's the first question going to be?
Proof.
Right, a proof. And give me an example. What am I going to ask you to prove?
Odd plus odd equals even.
Okay, something like that. Odd plus odd equals even. Or maybe I'll change it up. There are a couple of varieties I could ask about. I could ask you to prove even plus even equals even. Or I could ask you to prove even plus odd equals odd. What are the ways I could ask you to prove those things?
Picture proof or
Right. Could
algebra.
say do a picture proof, or I could say do a proof using algebra. Okay, so make sure you know how to do those things. They're not that difficult. You just need to remember the scheme for representing each kind of number. If you're doing picture proofs and you want to represent an even number, how do you do that in a picture?
You have the same amount of boxes on each side.
Okay, right. So you'll have a box, 2 equal rows. If you're doing even plus even, then you'll have 2 of those kind of pictures. What if you want to do an odd? How do you represent an odd number in a picture?
With one extra.
Okay, so you have 2 rows, but one of the rows should have an extra box. That's how you represent an odd. Okay, because an odd number, well, you can't break it into 2 equal groups. One of the groups will have 1 left over. That also kind of informs us how we do the algebra. If you're doing algebra and you need to represent an even number, it's going to be 2 times whatever. How do you represent whatever in math? What's the way we do that?
A letter.
Right, a letter, a variable. Okay, 2 times something, and that something could be any number. So 2k, 2l, where that letter represents anything that we could want to substitute in. So the scheme for representing an even would be 2 times something. How do you represent an odd in algebra? Right, plus 1. Okay, now notice the connection between the picture and the expression. Okay, when we had an even number, 2 equal rows. 2 rows of whatever. 2 times a variable. When we got an odd, we had 2 equal rows, and then one of the rows had an extra. 1 extra. 2 equal rows plus 1 extra. 2 times a variable plus 1. That's your scheme. Okay. So that's going to be the first question, and of course, on your playbooks, you listed out the other types of questions that are going to be eligible. Okay, so I've made a list. I have not entered this in Canvas just yet, but I've made a list of the people that have turned in their playbooks. I'm going to give them back to you for those of you that are in class today. For those of you in Zoom, I would encourage you to pick up your playbooks. I do have something to do, so I'm going to be leaving the office today at 3:30. I've got some stuff to take care of. So pick up your playbook before 3:30. That way you can use it to refresh your memory and study. Now remember, okay, I've got playbooks from quite a few of you, but if I don't have your playbook, you don't get to take the test. You get a 0 on the test. Folks out there in Zoom land, very serious. You get a 0 on the test. So playbook is the ticket. To the test. Okay. Let me do one little thing here. We had talked a little bit about factorials, and there was a quiz question that gave a couple people some trouble. Let me try to answer this question. How many zeros at the end of 10 factorial? How many at the end of 30 factorial? Okay, both of these were actually in the homework assignment where we talked about the distribution of prime numbers. We actually gave a proof in class that there were infinitely many primes. We had a little scheme for taking any list of primes, no matter how long it was, and we had a procedure for creating a new prime based on those numbers in the list. That was a little surprising in light of the fact that we could make these prime deserts, which is one of the things we were using factorials for, to make lists arbitrarily long of stretches of numbers that contain no primes at all. You want to make a list 100 numbers long that contains no primes? We had a way to do it. You can go back in your notes and check it out. Okay? Now here's the thing. This is of course what 10 factorial is. Okay? Now, some folks got the answer by actually doing the computation. That's not wrong, you will get the answer. The only thing is, it's a little bit of a slog for 10 factorial. For something like this, it's just about impossible. Okay, the factorial gets very big very fast. There's a way to do this without doing computations. There's a way to do it using logic. Okay? So let's look at that right there. That at the end. I multiply any number by 10. What happens?
You gotta do this.
Right, you put a 0 on the end. So whatever you got, you put a 0 on the end. So that is going to give us a 0. That gives 1 0 at the end of our number. All right, now, and this was what my hint was about, there's a 2, there's a 5. 2 times 5, of course, is 10, so that gives a 0. Now, 10 is the only number with that property. You can't multiply by 7 and end up putting a 0 on the end of it. That's not the way multiplication works. We have a base 10 place value system. So the only way to get a 0 is to have a factor of 10. Well, there's a 10. There's another 10. So how many zeros at the end of 10 factorial? 2. Okay, so 2 zeros at the end of 10 factorial. I want you to try to answer this one in your seats. Don't even try writing out 30 factorial. Even writing out the numbers will take forever. And definitely don't try to multiply them all. Okay? Your calculator might be able to do it, but it's not going to give you the digits at the end. It's going to give you the answer in scientific notation. Okay, so think about it with logic. And really, you don't even need to worry about 2's, because you've always got 2's. Every other number has a factor of 2 in it. You really need to worry about 5's. How many numbers have 5's? So think it out. 30 factorial. We know we're going to get a 0 when we hit it with a 10, and we know there's a 10 in there. What else is going to give us a 0? Okay, while you're doing that, I'll give you back your playbooks here. Amy, Madeline Morris, Emily King, Cynthia, let me see, I've got yours here. Leela, playbook there. Sarah Kirby, Raphia, let me see, Tasha, Corson. Okay, the playbook. Kelsey, Aspen, Bonnie, Madison. Other stuff here. Emily Pittsworth is in the other group. parse in a couple things here. Madeline, healthy. Brianna. Veronica. All these people. Oh, okay. See, Aspen, I got a mental math quiz here. Keisha, got a mental math quiz here. Leela. Leela. Rosie. Gracie, Aspen, there's that, Leela, Macy, Gracie, Susie, Keisha, Rosie. Okay. Got a lot of stuff from the other group here. All right. So, let's see. So we get zeros from what factors? Tell me some of the factors that are going to give me zeros at the end of this product. Okay, 10, 20, and 30. All multiples of 10 will give us 0. So 10 is going to give us a 0, 20 will give us another 0, 30 will give us a third 0. So we got at least 3 zeros. Are any other factors going to give us zeros? Okay, 2 and 5 will combine to make a 10, and that'll give us another 0. Okay, so really I'm just going to count multiples of 5, okay? Because you always have an even number in there somewhere to multiply by the 5 and get a 10, okay? So 5, we've already counted that, that's okay. So what do we need to count next? 15 has a 5 in it, and there's plenty of even numbers to multiply that and give us a factor of 10, so 15. Next thing would be 20, but we've already counted that. What next? 25. Now here's the thing about 25. 25 is tricky. How many 5s are in there? How many factors of 5?
5.
Well, if you're adding them up, there's 5 5s. If you're multiplying them, there's 2 factors, right? And the multiplication is what counts here. So that's going to give us 2 factors of 5, which will give us 2 zeros. Okay, so these guys give us 1, 2, 3, 4, 5, 6, 7. Okay? So there are 7 zeros at the end of 30 factorial. So, question that is actually easier to answer with logic than with computation. Okay, so you got to take a beat. Think about it before you start working. Most people say, okay, that's multiplication. I know how to multiply. I'm going to go ahead and multiply. This one you can do. It's not that hard. It's tedious because the number is getting kind of big. This one, you can't even, it'd be a pain in the butt to even write down the factors, let alone multiply all of them. Okay, but we can get the answer nonetheless by using logic, and that's the point of the question. Okay, we're looking for zeros at the end. We're thinking backwards. How do we get zeros at the end? You get zeros at the end of something by multiplying it by a 10. So the question is really asking, how many factors of 10 are in this problem? Well, we got those three. But then we got to realize, okay, anytime there's a 5 times an even, that's also going to give us a 10. So we really need to count factors of 5. In fact, you could just count up the 5s, not even breaking them up like I did. Okay. So something to keep in mind there. That was on a quiz. I may very well put that kind of question on the test. Okay, let's do some more word problems with fractions and stuff that involves division, etc., etc. I guess this is what, 6.4? Let me check elementary math for teachers here. Yeah, so section 6.4, 6.5. Okay, so the key ideas, of course, will be writing teachers' solutions. Remember, when I ask for a teacher solution on our test, I'm looking for bar diagram, computation, sentence. And in these particular word problems, we're going to be doing operations with fractions. Here's a quick example. Sam spent 3/4 of his money on an $18 book. Actually, I want you to help me out with this. What makes sense for me to ask? What should I ask?
How much money does he have left?
Okay, we could ask that. We could try and figure that out, because we know 18 was 3/4 of the money he had. So we would need a little intermediate step there. We would need to figure out how much he started with. Okay? So I could ask how much does he have left, or I could ask how much did he start with. Okay? They're kind of related questions. So let's go. Let's do the ones that who gave me the question? All right, I thought it was you. Okay. How much does he have left? Okay, so we'll do a bar diagram. How many pieces should I break up my bar diagram into?
4.
4 pieces. Okay, Gracie knew the number of pieces we needed. What did she look at to get that answer?
3/4.
Right, now in particular, we're looking at the denominator of the fraction involved. Okay, so 3/4. So we divide this up into fourths. Remember, of course, 3 cuts. Okay. So I want you to take a second in your seats, draw in what we know. We don't know the length of the whole bar, but we do know something. Okay, let me take a look and see what y'all got. Okay, good. Right. Okay, good. Right. Okay. Okay. Okay, good. What is that? That's something. Write down what we know about it. Okay, so 3/4 of his money was spent on the book. The book cost $18. So there's 18. Okay, now we could do it like this. 3 units of the diagram equals $18. This is what we really want to find. The amount that he has left, which would be that last block. So if we know 3 units equals $18, how much is one single unit?
18 divided by 3.
Okay, 18 divided by 3, and we can do that mentally. What do we get?
6.
6. Okay, so $6 left. Sam has $6. Okay, we could have asked, how much did he start with? Okay, now that we've done this work, the answer is pretty easy. So how much did he start with?
24.
$24, right? We can just take the amount he spent plus the amount he has left. The total must be what he started with. Okay? Now, if we hadn't done this already, let's pretend for a sec that we asked that question instead of this one. Okay, we could still use the same diagram, at least starting out. 1, 2, 3. So this is still 18 right there. The question we're trying to figure out now is not the last bit, though I guess we could do that. If we're asking what's the total length, we could do it this way. Okay, 3 units is 18, 4 units. Well, do this multiplication, 4/3 times 18. Okay, so this is how you work with a fraction like this here. At least this is how I would do it. Multiply by 4, divide by 3. You can do that work in either order. You can multiply first, or you can divide first. It's up to you. Okay, if you remember this, you remember what that is? What's it for?
Parentheses, exponents, multiply, divide, add, subtract.
Right, it's a little, I guess what they call an acronym to help us remember the operations, the order of operations. Well, it's a little misleading because it's really this. Multiplication and division are actually on the same priority level. Okay, so we can do them in either order. So I would actually do 4/3 times 18. I would do the division first. 18 divided by 3 gives you 6. 4 times 6 is 24. Okay, either way, we get that Pete has $24. Okay, so let's do some practice word problems. If you've got elementary math or teachers with you, crack it open to page 159. Go to page 159. Okay, you guys on my right, left side of the room, I want you to work on problem number 5A. You guys on the left side of the room, I want you to work on problem problem 5C. Okay, you guys are 5A, you guys are 5C. Okay, so I'm going to start with my bar diagram. How many pieces should I have? I'm going to break it up.
11.
I should have 11 pieces, okay? They told us in the problem she spent 5/11 of her money. So let me try it here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 10 cups. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is what she spent. And this is what she has left. All right, now how much did she spend? Okay, so yeah, so what did they tell us? Okay, she had $42 left. Okay, so this is the amount she has left, and this is $42, and then we're trying to find this. There's our question mark. Okay, so we can do our computation here. 6 units equals 42. Okay, so 7 units. There's a couple of ways we could do it, but you end up doing this either way. 7/6 times 42. Okay, you're going to divide by 6. No, I don't care about that. 1, 2, 3, 4, 5 units. 5/6 times 42. Okay, so you're going to divide by 6, multiply by 5. And we could express that with a fraction like this. So we get 35 there. Remember, it's usually easier to divide first. Because if you multiply, that gives you bigger numbers to work with, and that's going to make the computation harder. So probably best to do the division first. 42 divided by 6 is 7, times the 5 is 35. What was her name?
Alice.
Alice. Alice has $35. Okay. I'm going to need that. Yeah, thank you. Okay, so let's look at 5C. You folks on the left side did 5C. Okay, a little bit trickier because we got these two fractions. It's actually a two-step problem here. Okay, so we can tell he has 600 loaves of bread. Okay. Now, it tells us in the problem that he sold 1/5 of the shipment on Monday, and then he sold 1/4 of the shipment on Tuesday. Not 1/4 of what was left. 1/4 of the original shipment. Okay, that's important. And then they asked how many loaves were left. Okay, so we could have two bar diagrams on this one, if we wanted. We could take this and do it like such, right? 1/5 of the shipment on Monday. So this is for Monday, figure out how much you sold on Monday. That's the amount you sold on Monday. And then for Tuesday, I would still start with a bar of 600 because it's 1/4 of the shipment. I'd be looking for what is that. Okay. So actually, let's go ahead and do this. So what's the question mark here? The amount you sold on Monday, how would I figure that out?
Well, 5 units equals 600, so 1 unit would be 120.
Okay, so we can take 600 divided by 5, right? We know the total length, we got 5 pieces, so we take 600 and divide it by 5. So, similar thing here, 4 units is 600, so 1 unit is 150. I still have to do one more computation. I know how much you sold on Monday. I know how much you sold on Tuesday. The question is asking me how much does he have left? How do I figure that out?
You add 120 and 150 and
Okay.
subtract.
So we got 270 loaves of bread sold over the 2 days. We do 600 minus 270. Zeros don't matter. 3, 3. He has 330 loaves left. Now here's an alternate way of doing it. Okay, so we're talking about fractions of the shipment that have been sold. So on Monday, you sell 1/5 of the shipment. On Tuesday, you sell 1/4 of the shipment. Okay. So let's take a second and add these. What do I have to do to add fractions again?
Have a common denominator.
Right, gotta find my common denominator. Okay, remember, gotta put a question like that on the test, asking you to add fractions. I'll probably put 2 questions. I'll say, here, show me a picture with the area model that illustrates how to add these fractions, and then I'll probably give you one that you do abstractly, do the arithmetic to add these fractions, okay? What's my common denominator? 20. So what do I need to hit this with, top and bottom? Got to hit it with a 4. You have to use the factor that's missing. Your LCD, or I guess least common multiple of 5 and 4, is 20. So I hit that top and bottom with a 4. So 1/5 is 4 out of 20. 1/4 is 5 out of 20. So this is 9 out of 20. Okay, so 9/20ths, that's the total fraction of the loaves sold over the 2 days. This is how we can find the amount left. Okay, now where am I getting 11 from?
9 minus 20.
Right. By the way, flip it, 20 minus 9, okay? But same idea, okay? So, to figure out the total fraction of the loaves sold over the course of the 2 days, we're talking about how many 20ths, because that's the LCD. He sold 9 20ths. That means he still has 11 20ths left. Right? We're imagining breaking up that group of 600 loaves into 20 pieces. Okay, we take 4 of those pieces, that's what was sold on Monday. We take 5 of those pieces, that's what was sold on Tuesday. That gets rid of 9 of the groups. We had 20 groups, so there must be 11 groups left. How do we do this again? What should I do? How do I do this computation with the fraction?
Divide 600 by 20.
Okay, right, divide by 20, and then what?
And then multiply.
Multiply by 11. Let me write that step down. 600 divided by 20. Do I really have to do a long division here? Can I do it mentally? What do I do?
40 divided by 60.
Okay, right, so we're really focusing on the 6 and the 2. Okay, we really just need to do 6 divided by 2, which gives us a 3. How many zeros should I have? 1 0. Okay, so the 0 goes away. Do the 6 divided by 2, 1 0 is going to hang around. So I got to do 11 times 30. What's the mental math for multiplying by 11 again?
Times it by 10 and then add.
Okay, right, so hit this with a 10, 300. And then add 1 copy of 30. 330, okay? So these operations that we're doing here, they really are operations with fractions. Okay? Anytime you're doing a multiplication and then a division, or a division and then a multiplication, you can rephrase that as an operation with a fraction. Okay, let's go backwards. Let's start with the answer and get the problem. Okay, I'm looking at page number 6. So not page number 6. Page 159 still. Problem number 6. Okay, page 159, problem number 6A. So they give us a diagram. In fact, they give us 2 diagrams in 6A. I want to come up with a word problem that would lead us to those diagrams. So we're thinking about a word problem that would lead us to those diagrams. Okay, so what's the first thing we should say? Okay. So remember, we got the diagram, so let's kind of work backwards and think what would make us do those diagrams? What would make us set those up? So the first sentence, I'm thinking, should involve a fraction. What should the denominator be in my fraction? Okay, 7. We just count up the number of boxes in the diagram. So we got something that's broken up into 2 groups, men and women. How many, or what fraction of the group is women? Okay, 5 out of 7, okay? So, we could say something like this, 5/7 of a, what do you want the group to be? Could make up anything.
Basketball team.
Okay, 5/7 of a team. Let's put in basketball. Are women. Okay, 5/7 of a basketball team are women. Okay, now, that's not quite enough to have us do the whole problem yet, okay? We have to get something that would lead us to the second problem, or the second diagram. We have to have a sentence in here that would lead us to the second diagram. So what should I say in the second sentence?
There are 72 more women.
Okay, 72 more women than men.
That's a big team.
Yeah, so maybe we would go back and change that, but we'll just leave it. Okay, so maybe we'll say a basketball tournament or something like that. So there are 72 more women than men. And then we have to ask a question. So what question should we be asking? Right, and how can we tell what we want to ask that? Actually, I think, look at the diagram a little more closely.
How many?
Right, how many altogether? How many on the team? Now, how do we know from that picture it should be how many on the team and not how many men?
Because there's a bracket.
Right, let's look at where that question mark is. It's the total on the 2 groups in the second diagram. So how many people on the team? Now, we could certainly ask how many men. The diagram would be similar but not exactly the same. The question mark would be in a slightly different spot. Okay, but the setup would be the same. Okay? So, 5/7. Now, how do we know that should have been a 7 again?
How many pieces?
Right, how many pieces in that first diagram? Okay, that first diagram had 7 pieces, 5 of them were shaded. So they must have told us about 5/7 of something. Okay, and we knew it was men and women because they showed us that in the diagram. And then this second sentence, 72 more women than men. Okay, they didn't say there were 72 women, right? Notice the diagram is showing us that it's the extra, right? It's comparing the 2 bars and showing us that the bar for the women is 72 longer than the bar for the men. So that must mean 72 more men than women. And then we can go and get the total. Okay. So that's working backwards a little bit there. Writing a word problem that would make us do a computation. Okay, let me see here. Okay, let's try number okay, let's try let's try 7A. Sorry, 512 is 8/9 of what number? Okay, not much of a word problem. But let's draw a diagram and try and solve it. Okay, what was it, 7a was it? Okay, so 5/12 is 8/9 of what number? So let's start out with a bar diagram. And I know it says using algebra, let's do a bar diagram. How many boxes should be in my bar diagram? 9 boxes, okay, because it says 8/9. One, two, three, 4, 5, 6, 7, 8. Okay, remember, you want 9 boxes, you make 8 cuts in your diagram. Okay, I'm going to write something down. Is this right? Not quite. Right? What's the 5/12?
Just the 8.
Right, 8 boxes. So I saw some people had shaded it. Maybe we should do that. So 8 of those boxes give us 5/12. So what's the total length? What should I put up there?
Question mark?
I should put my question mark up there. That's what I'm trying to find. Now that's the bar diagram. We could very well do this using algebra. Okay, 5/12 equals 8/9 times what? Well, maybe we'll put an X there. Remember, when you see of, think multiplication. Or when you see multiplication by a fraction, think of. Like 1/2 of 200. 1/2 times 200 gets you the answer. Okay, 8/9 of what number? 8/9 times something. Okay, so if we're doing algebra and I need to unmultiply, what do? I got to get rid of this multiplier if I want to get the value of x. Okay, we can multiply by the reciprocal, right? So 9/8 times 5/12, that'd be x. All right, so take 5/12, divide by 8. Now, this is where our powers of 2 come in handy. What is 2 to the, oh gosh, 2 to the third, that's 8, okay? 2 power 3 is 8. 2 power 5 is 32. 64. 128. 256. 5/12. 5/12 is 2 to the 9. 2 to the 9, divide by 2 to the 3. What do the rules for exponents say? 2 power 9 divided by 2 power 3. Right, subtract the exponent. So we got 2 power 6, which is 64. Great. Okay, so this would be 9 times 64. That equals x. We're multiplying by 9. Hit it with a 10, and then back off 1 copy. 640. Take away 60. 640 take away 60 is, well, you take away 40, you got 500. No, sorry. Take away 40, you got 600. Take away 20, now you got 580. Take away 4, 576. Okay? Divide by 8, multiply by 9. And that's how you would get the total length of the bar. So 5/12 is 8/9 of 576. Okay. So, for homework, I want you to read chapter 6, section 5 in elementary math for teachers. I am going to put word problems on this test. There's going to be mental math on this test, there's going to be word problems on this test. Okay, so make sure that you can do all the parts in problem 5 on page 159. Page 159. All the parts on problem 5. It wouldn't hurt to review problems 4, 6, and 7 as well. Okay? So make sure you get practice with those bar diagrams. If you haven't handed in your playbook, I'm going to need your playbook before you take the exam. Okay. We'll see you Monday for the test.